We've already seen cases in which we have the curve that is above the x-axis and then we're supposed to find the area under that curve. But in some cases, the curve is actually going to be below the x-axis, and in that case, your area is going to come out to be negative. So we're just going to do that right now and see how that works. We have a curve over here, and that's basically given to us as this equation, and we can clearly see that we're supposed to find this area right over here, and the curve is actually below the x-axis. So when we are going to use integration to calculate this area out, you guys will see that it's going to come out to be negative. If we were supposed to, let's say this curve did something like this, and we were supposed to find this area instead, that would have actually been positive. But since this is below the x-axis, this is going to be negative. So how do we find the area of this region? Well, we can integrate, so we know that we are going to sum up. So we're going to sum up the area of tiny rectangles, and that's just going to be the height of those rectangles multiplied by the width of those rectangles, and obviously the height is going to be given to us as y, because the y-axis is representing how tall or short something is going to be, right? And then we need two limits, we need two bounds between which we are trying to calculate the area. So if I draw this graph something like this, then you can kind of see that we are trying to find area between this point, right, and this point, between these two limits. So what is the x-coordinate between these two limits? What are the x-coordinates of these two limits? Well, if you look at this limit over here, it's clearly given in the question that that is equal to 1. Now, what about this one? Well, if you look at this line, or you look at this this limit, this is kind of the y-axis, right? And so the y-axis, you can clearly see that the y-axis is intersecting the curve intersecting the x-axis at this point, right? And what's going to be the x-coordinate at this point? Well, it's going to be 0 because it's the origin. So we know that the lower limit is going to be 0 and the upper limit is going to be 1. So we can write that over here. And then we know what y is equal to. We have been given the equation of y, and that's basically 1 by 2. Then we have x to the power 4 minus 1, and then obviously our dx. So, okay, now we have an integral. We already know how to solve integrals. We've done this many times in the previous videos. So, first of all, you can kind of realize that that right there is a coefficient. It's being multiplied with this entire thing. So how about we pop that outside the integral? Now it's just going to be this thing, x to the power 4 minus 1 dx, and you can kind of see that this bracket has a power of 1. Since it doesn't have an explicit power of 2, 3, or 4, it's obvious that the power is 1. And so another way I could write this is basically like this. And what do I do now? Well, how do I solve this? Well, I know that if I split this integral into 2, then I could solve it in the form of x raised to the power n. And that's exactly what I'm going to do. So I've identified what form I can integrate this in. And so I'm going to try and turn this integral into that form over there. And so it's just going to be, I can split this integral into 2. And so it's just going to be this thing, x to the power 4 dx. And then it's going to be this thing. And now I'm just supposed to sort of integrate it. So I know this is going to just become into, I can use this, the integration of this, which I know integrates to x n plus 1 divided by n plus 1. So that's no big deal over there. If I look at x raised to the power 4, all I got to do is turn it into x raised to the power 5 and then divided by 5. And then over here, since I don't have an x, I have x to the power 0. So that's just going to turn into x to the power 1 divided by 1, and so that's just going to become x to the power 1, and I don't even have to write the 1 explicitly. It's understood that this thing is raised to the power 1, right? And I've basically integrated this, and now I can finally put my limits over here. Now you could have added your limits over here as well for both of these, since you separated the integral. You split the integral into two parts, into this integral and this integral. So you could possibly apply separate limits for this and this. Now, why I didn't do that was because I'm going to save time over here. And plus, you can kind of see that this thing that I have right over here, so if I can just, this thing that I have right over here, this entire thing, this basically came out of this entire thing, right? I just did this intermediate step over here, but in reality, this thing right over here is coming out of this thing right over here. Originally, it came out of this whole integral, and this whole integral had a limit of 1 and 0. So instead of, writing the limits for this thing and this thing, I'm just going to write the limits for this entire thing and make my process a lot easier. So that's what I'm going to be doing. 1 by 2, and anywhere you see x, you're going to first place 1, and then you're going to subtract, and then anywhere you see an x, you're going to put 0. So that's basically going to look something like this. It's going to be 1 raised to the power 5 divided by 5 minus 1, and then I'm going to subtract. So now I'm going to put zeros, so that's going to be a 0 right over there. I'm going to have a 0 right over there, and so this thing is just going to turn into zeros, and then this thing is going to evaluate to, I guess, negative 0.8. Right? And since now we only have negative 0.8 left, when you multiply it by this thing, what is this? This 1 by 2 is basically, 1 by 2 means half of something. So this negative 0.8 is just going to turn into negative 0.4. And you're going to get an area of negative, right? So that negative basically represents that your curve is below the x-axis. So whenever you calculate an area and it comes out to be negative, that just means that your curve is below the x-axis. Now, using that same idea over here, I saw a question like this in the past papers, and how do you solve this? Well, the question is given to you that you need to show by calculation that area A1 and area A2 are equal, okay? And then this curve is going to have some equation, f of x is equal to something, something, something. And so you're supposed to show by calculation that this area right here is equal to this area. Now, you already know that both of these things are equal because you've already been told that in the question. You just have to prove it using some calculations. So we know that we can find the area under curves using the process of integration. So we know we got to integrate over here. And then we can clearly see that this part of the curve is above the x-axis, but then the next part, this part right here, is below the x-axis. So you're going to actually get a negative area for this part and a positive area for this part. Now, when you are going to integrate between between origin and A, you are going to get a positive answer. So let's say your A1 comes out to be positive 8. And then when you integrate between A to B, you're going to get a negative answer. So let's say your A2 is going to be negative 8. Now the negative and positives don't matter because all they're telling you is where the x-axis, where the curve is situated. Is it situated above the x-axis or is it situated below the x-axis? So they don't really matter, but these numbers do matter. And if both of them are 8, I'm just assuming they're 8, if both of them are the same, then it's clear that A1 and A2 are equal. However, if you integrate this entire curve, right? If you integrate, let's say you integrate this curve f of x dx, you integrate it from origin to B, and you don't take this A into consideration, and you don't take the fact that it's above the x-axis over here and below the x-axis over here, and you just integrate this entire thing, you are going to get an area of 0. Now, the reason that happens is because, well, if you look at the first part, this part right here is going to be positive, this part right here is going to be negative, and obviously they're both equal to each other, so it's just going to be plus 8 minus 8, and you're going to get an answer of 0. And then it's nothing wrong, getting an answer of 0 isn't wrong, but you need to explain how getting a 0 shows that area A1 and A2 are equal. And then you can basically explain this idea that, well, A1 when the area A1 is between the curve and the x-axis, but the curve is situated above the x-axis. So I'm going to get a positive area, and for A2 I'm going to get a negative area because my curve is below the x-axis, and since they both are equal, I'm going to get an answer of 0. If they were not equal, then I would not get an answer of 0 and I would get something else. So since I got an answer of 0, that proves that A1 is equal to A2.